separating into the oxyorganic compounds. Oxyorganic compounds means they're organic compounds, carbon and hydrogen, with at least an atom of oxygen thrown in different variations. Sometimes we'll have two in there. So this is actually going to be dealing with 7 classes of oxyorganic compounds. All right? And you know, the alcohols, ethers, ketones, carboxylic acids, aldehydes, esters, and the aforementioned amines. Because it's 6 oxyorganic and 1 that doesn't have any oxygen, which instead has nitrogen, we call those amines. They, along with the carboxylic acids, form the amino acids. So this is real important stuff. Now, when you hear the word alcohol, I know you kind of go, oh, I know what alcohol is. You really don't. You don't know. The alcohol that you're familiar with is one of literally thousands and thousands of alcohols, all of which, with the exception of 2 or 3, are toxic. You cannot drink it. Ethyl alcohol is toxic when you reach a certain level. You can die from drinking too much alcohol. But the human body is able to digest it in such a way where it deems it much more harmless than it could be. Although I just read a few articles not too long ago saying that alcohol consumption gives absolutely no value to the human body whatsoever, outside of recreation. I would keep that in mind. I know I have. I haven't had hardly any alcohol in a long, long time. So what we're going to do in all these 7 sections is that we're going to look at some certain aspects. So we're going to look at the physical properties of these compounds. We're going to look at uses for them. We're going to be looking at nomenclatures. That's a big part of this discussion. And lastly, we're going to come up with what we call synthesis reaction. We're going to come up with one synthesis reaction for each one. We could spend a long time on synthesis reaction. Now, to refresh your memory, a synthesis reaction is a reaction that creates the compound that we're looking for. Like I said, there are, in some cases, dozens of them that you would have to know if you're going to go into some kind of medical engineering or even medicine itself. You're going to be asked to know a lot about all the oxyorganic compounds, because the human body does have to deal with a good portion of it. So this is going to be a fairly intensive section. Now, the homework is going to be based upon the nomenclature, but this other stuff is going to help you if you go through this and digest this as best you can. This is going to help you in future organic classes. But we are going to deal with the nomenclature mainly for the practice problems. So let's go back to the top. Let's talk about, you see, first of all, let's deal with the definition. How do we know we have an alcohol? Well, here is an example of the simplest alcohol that we know. This is methanol. Now, this is the part of the compound that makes it an alcohol. The overall symbolism of any alcohol is ROH, where R is an alkyl group. Now, because we are doing just a limited amount of organic chemistry, all our alkyl groups are going to be derived from alkanes. It is possible to have an alkene or an alkyne be an alcohol. We are not going to deal with that. We're just going to deal with the alkyl group. So this is how we define it. You can sometimes see it defined as a bond, a single bond between the R and the O, but also know that the ODH is a single bond as well. It's just so common we don't put it in there, but keep that in mind as we go through as well. It's not a conjunction of OH that is some magical group that is put on there that doesn't look like the rest. It is literally an oxygen with a hydrogen, and that oxygen has another electron to form a single bond with the carbon chain that is the alkyl group. Okay, so that's how we define alcohols. Next, we're going to talk about physical properties. Now, alcohols are a very, very important aspect to organic chemistry. It is very common. It's found in a lot of forms throughout nature and in the human body. Let's take a look at ethanol, which is the one that you guys know. When I look at the Lewis-Dot structure, you'll notice here that you have an electronegative oxygen here. And this is a bent structure, so in actuality, it should look something like this. And then your pair of electrons right here, giving this side a negative sign, it's a negative like part of the molecule. And this is slightly positive over here. There is a tendency of separation charge, not a complete separation charge, but it's strong enough where it's like water. Water and alcohols are very similar. The difference is this is not as strongly bonded because of these bulky carbons here kind of weakening that thing. But this is a pretty effective molecule in terms of polarity. This is a polar molecule. And polar molecules will dissolve in water. So this is soluble in water. The thing about that is if you get this chain or over here and it starts to get long, these things don't stay that way. They start to wrap around. It turns out that when they move around within each other or in other substances, they use the least amount of drag possible to get through that, and that is when it takes on a spherical shape. So these carbons start to shield this oxygen. And it gets to the point where water or any other polar molecule is not able to dissolve it. So we say a soluble water up to around 6 carbons, usually 6 to 7 carbons, mostly in that range, a little bit 5, a little bit 8 or something, but in the average 6 to 7 carbons, right around 6 carbons. So it may be a polar molecule, but if it gets to a certain point, it stops acting like it's polar. Okay? Now, because of that polarity, it is the bonding, the intermolecular bonding. We talked about this way back in the first chapter. We said there are 3 types of covalent intermolecular bonds. Let's see if you can think of this as we go through this. One is the hydrogen bond. And that's the strongest. Then dipole-dipole. And then we have van der Waals forces. Which I've also called London dispersion forces. Evidently there's a difference, and I didn't know that. And I thought they were the same thing because 2 guys are describing the same thing. But evidently there's some out there, so I'm going to have to do some more reading on that. But regardless, in this case, because you have a hydrogen on the oxygen, it's going to bond to another ethanol that has a hydrogen-oxygen combination. The hydrogen will latch onto this because it's polar. This is positive, that's negative, and you get this chain. And which is why alcohols tend to be not as smelly as some of the other organic compounds because they're bonded so tightly. Remember, smells are the result of an organic compound that collides with the sensors in your nose, then your brain translates that as a particular smell, and then you identify it by that. If it is held tightly, you don't have as many molecules colliding with your nose. The next one we're going to get into is ethers, and ethers are held by dipole-dipole bonds, and they just collide. You know you've opened an ether bottle when you open them. These, you can smell the alcohol, but it's faint compared to some of the others out there. Okay? So, that means then that it's going to have comparatively low vapor pressures. When I say comparatively, I mean compared to other molecules of approximately the same size or same mass. That's a key point. When we talk about its higher boiling point, lower boiling point, higher vapor pressure, lower vapor pressure, we're comparing other molecules right around the same molecular mass as this. In this case, the molecular mass of this is like 46. So you want to see other molecules like between 40 and 50 and how they interact. Are they approaching the same vapor pressures, all that stuff? Well, it's going to be low for alcohols because of the tightness of the hydrogen bond, which means then that the boiling point, if they have low vapor pressure, the definition of boiling point is when the vapor pressure hits the atmospheric pressure. If this is low, it's going to take longer to get to the boiling point. So the boiling point is low in comparison. Blah, blah, blah. So we're going to be doing that throughout this chapter. We're going to be looking at comparisons. We're going to say high or low. All right? Next.